This conference will now be recorded.
First of all, first and foremost thing that I want to ask you, I know that there are some disturbances in the class in the last class, but sorry for that. Anyways, did you understand the concept what we have cleared out? Guys, response. Any questions from the last class?
No, sir.
Okay. So let us discuss about the next topic. Okay. So in the last class, we discussed about the configuration related to AWS VPN configuration, how to create a VPN and how to transmit the data securely from local to destination through the over the internet, and as well as we are creating a tunnel and encrypted manner we are transmitting the data. Now today we are going to discuss a very new topic. It is not very new for you, but the point is, now can you tell me what is the main drawback of VPC peering? We discussed about this. What is the main drawback of VPC peering?
We have to create multiple BPCs. Their number of BPCs are more.
VPCs are more, obviously if there are multiple VPCs. So the point is,
If
any network,
VPCs
yeah,
if VPCs increase means the complexity, connection complexity will be high, sir.
exactly, exactly, very good. So any network engineer is there? I know whoever are working as a network engineer also, if you are not a network engineer also, that won't be any problem. For example, there are some computers in your company. So if here you need to understand, the point is there are multiple computers. Try to understand. I am connecting with your computer networking terminology. Here you are having four computers. Now, if this four computers has to communicate with each other, actually computers won't pass the data to flow through them. So here computer 1 should be connected with computer 2, and as well as computer 1 should be connected with computer 3, and as well as computer 1 should be connected with the computer 4, like this. So here computer 1 and computer 2 are interconnected. So we need to interconnect computer 2 to communicate with computer 3, and computer 2 to communicate with computer 4. You need to have the connectivity like this. And as well as the computer 3 must have the connection to the computer 4. If you see how many connections are there, if at all, if you are having four computers, 1, 2, 3, 4, 5, 6, you are having 6 connections. Now, to only if at all if you are having four computers, you need to maintain 6 connections, and that is very tricky. If at all if I am having some 10 computers, so then the formula will be n into n minus 1 by 2. Then it is equal to 45 connections I require. So to overcome all these problems, what I am going to do here, I am going to connect a centralized hub. I am going to connect all these computers to a centralized hub, and that is called as a switch, where I am going to connect all my computers to this hub. Okay, actually I am going to connect like this. Whenever I am connecting all my computers to the switch like this, then what is going to happen? The data will be, first it will be forwarded to the switch, and from the switch it will be forwarded to the computers, and from the another computer it will be forwarded to the switch, and from the switch it will be forwarded to the another computer. Here you are having a centralized device which will be helpful for you to transmit the data for the multiple computers. In the same manner, here if at all if you are having multiple VPCs, the problem is again, for example, if I am having some 6 VPCs, if I am having 4 VPCs, then how many number of peering connections that I want 6 peering connections like this. From VPC 1 to VPC 2 I want a peering connection, VPC 2 to VPC 3 I want a peering connection, from there I want a peering connection, like this I want multiple peering connections. So if I add a new VPC and that VPC has to communicate with all the other VPCs, then again I need to establish the peering connection. Then again what I need to do here, if I am going to, so if there are 4 VPCs, then these 4 VPCs require 6 peering connections. Then these 4 VPCs require 6 peering connections like this. If I am having 8 VPCs, then if I am having somewhere like 6 VPCs, again I am going to create 2 VPCs. Again, these 2 VPCs need to have the communication. These 2 VPCs, if VPC4, VPC5 has to communicate with VPC6, definitely it need to have a peering connection. And as well as if I with all another VPCs, the VPC should have the peering connection, which is a very tricky one. Here you can see, which is a very tricky one. So the number of peering connections will be keep on increasing. So to overcome this problem, what we are going to do here is to make it very easy. We are going to create a centralized hub. So that is called as transit gateway. We are going to connect to a transit gateway. What is this transit gateway? Transit gateway will act like a centralized hub to make the interconnection between the multiple number of VPCs that will overcome the limitations which is created by the VPC peering. So here we don't need to have multiple peering connections. We need to have multiple connections, multiple VPC connections between transit gateway attachments. They are called as, they are in transit gateway. We are not going to call them as connections. We are going to call them as attachments. So if you see here, how many VPCs I am having? I am having 3 VPCs. For example, this is my dev VPC. This is my dev VPC, and this is my prod VPC. Okay, and this is my somewhere like I will call it as a testing VPC. Test hyphen VPC. And the CIDR which I am going to provide for all these VPCs as I already have dev VPC, that is with 192.168.0.0. In the last class, from the first class onwards, we are having the VPC connection here. If you go to the VPCs, here we are having a development VPC with the CIDR as 192.168.0.0. So I already have a development VPC. Now we need to create a prod VPC and test VPC. Don't worry about that. We can create very easily. Create the VPC and more. What is the VPC that I want? Prod. And the CIDR is, I will go with 172.16.0.0/16. And I just want only one availability zone. I don't want more availability zones. One public subnet is more than enough. I don't want any private subnet. 172.16.1.0/24. Okay, done. And we don't want any NAT gateway and any endpoint. Create the VPC. Now the production VPC is created with the CIDR 172.16.0.0. Here you can see the CIDR is 172.16.0.0/16. I just created a VPC with this. Okay, and we have created a subnet also. We just created a subnet inside this VPC, and that is called as prod subnet with the CIDR 172.16.1.0/24. That is the CIDR of your subnet. Now what we are going to do, we are going to create the what I can say, we are going to create the server inside that VPC. Let us consider this is as a server. So inside the prod VPC, I am going to create a server. Okay, in the development VPC also I am going to create a server. In the dev VPC also I am going to create a server, and as well as in the test VPC also I can create a server. Like that I am going to create 3 servers in 3 different VPCs. Okay, so let us go back and create the test VPC also. Create VPC and more. So this is my test hyphen VPC, and the CIDR is 172.17.0.0/16. This is the CIDR of my VPC. Sorry, yeah, /16. And I want only one availability zone, and I want only one public subnet. I don't want any private subnet. And the CIDR is 172.17.1.0/24. Okay, we don't want any endpoints, so create the VPC. The VPC is also created. The second VPC is also created. Now here you can see this is the CIDR of the second VPC or test VPC which we have created. Okay, hold on. This is the CIDR. Done. Now what we are going to do here is we want to establish the communication between the multiple VPCs. How we can establish the communication between the multiple VPCs? That is the point. Okay, done. Now, as we have seen this, we have created all the VPCs. Now, let me go back to the subnets. First of all, prod VPC. Let me go to the prod VPC. Already we have two VPCs in the development VPC. And when I go to the prod VPC, so what I can do, actions, edit subnet settings, enable auto assign public IPv4, save it. And when we go to the routing table, here there is a question for you. So how many number of routing tables that we are having? For the prod VPC, we are having two routing tables, right? Here you can see there are two routing tables for the prod VPC. Why we got two routing tables? I already said about this. Any responses from your end?
We are not allowing the internet traffic to be communicating with the public subnet, so we use different routing tables.
No. So here the first thing what you need to understand is whenever we are, see, in creating VPC, we are using two tactics. Here you can go for VPC only and VPC and more. Whenever we select VPC and more, what is going to happen? So AWS will create one routing table. It's a public routing table. But one thing what you need to understand here is whenever you create the VPC, when we create the VPC, what are the things that will be automatically created with the VPC? What are the services which will be created automatically?
Security groups, route
Routing
table,
tables, security groups,
A route
NSL.
table,
NSCL.
security group, and NACL. These are the three things that are going to be created with the VPC. So which means that, so for the first step, whenever we are creating this, if I go for create VPC, what is the first step? It is going to first create the VPC. So it is going to create the VPC. Whenever it creates the VPC, what is going to happen in the backend? A VPC will be created. With VPC, we will have a routing table, and as well as we will have the security group, and we will have the NACL which is going to be created. And after that, it is going to create its own routing table, that is public, RTB public. So that is the second routing table. So here you can see in the routing tables, so here you can see main, yes, and here you can see main, no. What is the meaning of this? This is the routing table which has been created whenever the VPC is created. If you see main, yes, that means that routing table is created at the time of creating the VPC. Now, this is the routing table that is created by your AWS corporation. So AWS is creating another routing table. And in this routing table only, whatever the routing table public you are seeing here, in this routing table only, you will be having the routes. Like what is the routes that you are having here? See here, what are the routes that we are having in that prod routing table public? Can you specify the routes? What are the routes that we have?
Local and public, sir.
Local and public, very good. So we are having local and public. So and the subnet is also associated. So it is explicit association. So manually it is assigning the subnet to this routing table. So this routing table is the default routing table, and this routing table is created manually. So what I can do here is to overcome this to overcome this confusion, I will make this RTB public routing table as the main routing table, set as main routing table. Whatever the default routing table you are having, I will remove this. Why? Because we don't have any routes also. We don't have any subnet associations also. So it is useless. We can remove this. If you want the main routing table, you can remove the public routing table also. That's completely your wish. If you want upside down also, you can do that. Okay, so now we are having only one routing table, that is prod-rtb public. And for testing also you are having two routing tables. This is testing default routing table, and this is the manually created routing table. So what I can do here is I will set this routing table as the main routing table, and I will remove this routing table as the routing table. So here you can see this belongs to the test VPC. I will remove this. Let me delete it. Okay, done. Now when I go to the security groups, here I need to configure the security groups. Tomorrow, means Monday onwards, you will go with the security group configuration also. So it is my what I can say, it is my prod hyphen security inbound rules, edit inbound rules. I am going to allow all traffic. Simply I am going to allow all the traffic anywhere. Save it. Done. So this is my test security. This is my test security. Without seeing that, how can you say that, sir? So we are having three VPCs, and for three VPCs we will be having three security groups. First security group is named as a dev security group, and second security group is named as a prod security group. What will be the third one? Obviously that will be a test security group. Okay, edit inbound rules, and I am going to allow all traffic also. So here, edit inbound rules, add rule, all traffic. Done. So the security group is also configured. Now we are going to create the servers. Now we are going to create the servers. Let me go to the EC2 instances. I think I already have a server on my development environment. Let me check. Hmm. Here you are having a server, and this server belongs to which VPC? Here you can see the server belongs to the development VPC, development public subnet. Let me go to launch another instance. So you want, if you want, you can launch an instance in the development VPC also, which is already launched. I am going to create a server, that is my prod hyphen server. You can select any Linux. I will go with Amazon Linux only. T2 micro, and key pair will be AWS common key pair. Select an existing security group. First of all, you need to select the VPC. In prod VPC, select an existing security group, and the security group is the default security group, and launch the instance. In the production environment, we are having a server. Here you can see this is my development environment server. What I can do, the name is dev hyphen server. Okay, done. Now I can launch another instance in the testing environment, test server. Test hyphen server. Amazon Linux 2 T2 micro. Key pair will be AWS common key pair. In which VPC you want to create it? I want to create the server in the test VPC. Here you need to enable the IP address. I did not enable the IP address in the subnet mask. In the subnetting, in the subnet, we did not enable it. So I have enabled now. Okay. Select the existing security group. Launch the instance. So here you can see three instances are deployed. As per the diagram, here you can see in three VPs we deployed the three instances. This is my development server, production server, and the testing server. Now if they have to communicate, let us access the servers. Let us access the three servers. Ubuntu. It's a Ubuntu operating system. The first server is a Ubuntu operating system, so that is the reason. What I can do here is done. And the second server is my, here you are having the second server, new session, EC2 hyphen user. Let me access the server. I will change the color so that you can clearly understand. Appearance, colors, default foreground will be somewhere like, I will go with the blue color for the production server. Let me access the test server. New session, ec2-user, load, provide the IP address. When you open this, this is my test server. So change the settings. I just want to change the color. I'll go with green. Okay, so these are the three different servers which you are having. Now what we can do here is we need to install some configurations. I will install that. Sudo su hyphen. In Ubuntu you will have tmux. In Ubuntu you will have the tmux. Let me do one thing. Tmux control B shift 5. Control B shift 5. Okay, like that we can do, or else there is an option here. I think control B shift slash, or else shift double quotations. I think control B, yeah. So this is how I am going to differentiate the terminal. So we have the three terminals. So what I can do, control B up arrow, control B left arrow. Okay, done. So we have made the single terminal into multiple terminals using the terminal multiplexer. I'm going to do the same with all remaining all the servers. Sudo su hyphen yum update. It's an Amazon Linux, so you have to use the yum update and yum install tmux hyphen y. Let it install. Okay, done. So again, tmux control B percentage. The terminal will be divided. Shift to 5. If you press a shift to 5, it is percentage. The terminal is going to be divided into 2. And again, control B double quotations. It is going to be divided into the half of the terminal. Control B up arrow, control B left arrow. That's it. So now we have installed the tmux. Let me install on the third also. Yum update hyphen y, yum install yum install tmux hyphen y. Okay, done. Tmux, we require only 2. That's more than enough. Here also I will make it as control B right, control B left. Sorry, control B right, control B down arrow. I will exit from this. Okay, here also we require the same. Control B left, control B down, exit. So this development server has to communicate with ping. What is the production server IP address? If you see the production server 172.16.1.208. So 172.16.1.208. This is the production server IP. So my development server wants to communicate with my production server. And the next one is control B left right arrow. What is the testing server IP address? 172.168. Ping 172.17 1.198. So you will not get any response. So here, okay, it is saying that destination host unreachable. Okay, no problem. But anyways, here you can see we are not getting the response from any of the servers. Okay, control B here. Hold on. Okay, let it be there. Now what we have to do, first of all, as there is no communication from the servers, we need to create. So all the VPCs are distinct. They are not connected with each other. Now what we are going to do here is, we are going to create a centralized hub. How we can create that? Go to the VPC. In VPC, you are having transit gateway. Go to the transit gateway. I already have a transit gateway. Let me delete it. Create a transit gateway, AWS B13, AWS B13 hyphen TGW. You don't need to provide anything else. create the transit gateway. Now a transit gateway is about to create. So it will take its own sweet time. Now when the transit gateway is getting created, what we have to do here is, after the transit gateway is created, now if you look into this diagram, do we have any connections between the VPCs? Do we have any connections between the VPCs?
No.
No, sir.
No connections are there. So we need to establish the connectivities. Those are called as transit gateway attachment. So this transit gateway should be connected to your, or else this VPC should be connected to your transit gateway over the transit gateway attachment. Okay, like this. And this production VPC has to communicate, or else has to transmit the data. It should be connected to your transit gateway, and as well as the testing VPC should be connected to your transit gateway, as like in the previous example I shown you. Like every computer will be connected to the switch, in the same manner every VPC will be connected to your transit gateway. So what are these are called as transit gateway attachment. So what is the name that I am going to provide here is dev-tga transit gateway attachment, and this is my prod-tga, and this is my test-tga. These are the three transit gateway attachments which we are going to create. Now let me go back to the VPC configuration. Here it is created. Now the transit gateway is created. Let me go to the transit gateway attachments. Create a transit gateway attachment. Now this is my dev-tga. The transit gateway is to which transit gateway it has to attach. Obviously it has to attach to my AWS B13 transit gateway. Attachment type is VPC. From VPC to the transit gateway we are connecting. So the attachment type is VPC. We are having multiple types, VPN, peering connection also, but we are going with a VPC. Okay. And the next one is which VPC, from which VPC you want to connect. Obviously from the development VPC I want to connect. Create a transit gateway attachment. Now from this development VPC we just created a transit gateway attachment. Now the next one is from the production VPC we need to create a transit gateway attachment. Prod-tga. What is the transit gateway? This is the one, VPC. What is the VPC ID? Prod VPC. For the prod VPC we are creating it. Create the transit gateway attachment. Done. Second transit gateway attachment is also created, and we are going to create the third transit gateway attachment, that is test-tga, AWS B13. And what is the VPC? Test VPC. So three transit gateway attachments are created between three different VPCs to this transit gateway. Now the point is whether the communication will be started. Now that is the question, whether the communication will be started between the servers. Let us see. Here if I go with this, see that communication is not there, destination host unreachable. If I go with this also, I don't have the communication. That's what I have to do now. So for that, what I am going to do now here is, so what I have to do, guys, if I want to establish the communication, what I have to do?
Start the service.
No. Guess what I have to do to establish the communication.
Add a route that for some
Exactly.
destination.
Exactly. We need to add the route for which destination. So I will go to the routing table. Here we are having dev route, public route. Go to the routes, edit routes. So 192.168, this is my VPC. So here you need to understand the point is, if the development server has to communicate with the production server, first of all the data should be transmitted to the transit gateway. So via transit gateway attachment. So that is what the route. So here if I want to communicate with 172.16.00/16, 172.16 in the sense that is my prod VPC. From development VPC to the prod VPC, then the communication has to be happened through transit gateway via transit gateway attachment. Again, 172.17.00/16. Which CIDR it is? 172.17 means my test VPC CIDR. If the development VPC has to communicate with the testing VPC, then the data should be transmitted over the transit gateway via transit gateway attachment. Save the changes. So if you see the diagram, for any VPC, the data should be propagated to the transit gateway via transit gateway attachment, this through this attachment only. Okay, so don't get confused. And the next one is for the production VPC also I'm going to do the same. For the prod routing table, routes, edit routes, 192.168 0.0/16. What I can do here is 172.17 0.0/16. That is my testing VPC. The data should be transmitted to the transit gateway via transit gateway attachment, transit gateway via transit gateway attachment. Save the changes. And next what I can do, again I am going to create the routing table on the test VPC. For all the VPC we need to create the routing table. Edit the routes, 192.168 0.0/16. Again 172.16.0.0/16. Then the communication should be happen with the transit gateway via transit gateway attachment. Transit gateway via transit gateway attachment. Save the changes. Now you can see there will be a communication. Look at that. There is a communication that is established from your production server to your, what I can say, 172.16 in the sense development server to your production server. And as well as there is a communication that is established from your development server to your, what I can say, it is saying that destination host unreachable. Hold up. You should not say destination host unreachable. Anyways, what is the IP address of this? 172.19. Let me do one thing. Ping. What is my development VPC development server IP address? 192.168 1.157. 192.168 1.157. Interesting. The communication is not established. Let us see. No problem. If I go with the ping 172.16.1. What is the IP address of my production server? 208. 208. I'm getting the response, but there is a miscommunication between development VPC and the production on the testing VPC. Why? What happened there? We need to check out that. First, let me go back to the VPCs here. 172.17.00/16. If I go to the subnets, 172.17 1.0, that is fine. If I go to the routing table, routes, transit gateway, everything is there. Okay, 172.17.00 is there. Good, fine. What is the test server IP address? 172.17 1.191. That is 198. That is what I have provided over here. It is saying that let me do one thing. I will restart the server once. Okay, hold on. Okay, so let it come. That will be, we don't need to worry about that. So the next thing what I'm going to do here is, after configuration of this, the next point is, this is between one region. If there are some backup VPCs in the another region, so there is a backup VPC in some Ohio region. I'm having a backup VPC in the Ohio region, and there is a management VPC in the same region. You know that. So between these two VPCs, if you want to establish the communication, we will be creating a transit gateway. So through the transit gateway, what is going to happen? So these VPCs will communicate with each other. The resources inside these VPCs will communicate with each other. Now the point is not about the communication within the same region. The point is, if the VPCs has to communicate, if the VPCs has to communicate with the opposite region VPCs, how we can make the communication? That is the question. So to make that communication, what we are going to do here is, to make that communication, what I am going to do here is, so here we are going to create here we are going to create a peering connection. So between these two transit gateways, we are going to create a transit gateway attachment that is called as peering attachment. So we will see that. So what I am going to do here is, let me go back to the Ohio region. In this region also, I am going to do the same. Okay, I will go to VPC. Let me go to the Ohio region. Hold on. Let me check whether we have the communication or not. Why it is saying that destination host unreachable? We have the configuration properly. Security groups. Hold on. Let me check the security. It is allowing all the traffic to enter. We don't find any problem with that. Okay, we will look into that later. But as of now, I will go to the Ohio region. In Ohio, we are having two VPCs. One is the management VPC and the backup VPC. We already have that 10.100.0.0, 10.200.0.0. We have the two VPCs. Now we can deploy the two servers in those two VPCs. Launch the instances. Backup. This is my backup server. Backup hyphen server. Ubuntu mission. You can go with any Linux, no problem. I will go with the T2 micro. Key pair will be AWS common key pair. In the backup VPC, I want to create it, and I just enable the public IP address, select an existing security group. I already configured all the things. Okay, launch the instance. So we are going to create one more instance in the management VPC. So launch the instance. This is my mgmt-server Ubuntu mission, and I will go to AWS common, and I want to create this in the management VPC, and let me enable this, select an existing security group, default, and launch the instance. So two instances are created in the two different VPCs. Now if I want to establish the communication between those two VPCs, what I can do, let me access those two servers. Okay, new session, Ubuntu @ provide the IP address. This is my Ubuntu server which is deployed in the Ohio region. To make you understand that, I will just change the color. This will be red color. Modify, this will be a red color. Okay, so this is my backup VPC. Whatever the VPC is there, this is my backup VPC. Let me access the management server. Copy the IP address, go to the backup server, new session, provide the IP address, Ubuntu @ provide the IP address. So now you are going to connect. That's it. So I will change it for your understanding purpose. What I can do, change the settings, colors. The foreground color will be black. Okay, and the background color will be white, so that it will be very clear for you. So this is my management server. Whatever the server that you are looking, this is my management server and this is my backup server. So what I can do here, as you can see, both the servers will not able to communicate with each other. Here you can see ping 10.100.1.114. We are not going to get any response. We are not getting the response from the server, from the backup server. Ping 10.200.1.199. I'm not getting any response from the management server also. To make the communication, what we have to do here, let me go back and create a transit gateway. So this is my AWS B13 hyphen PGW hyphen Ohio. I'm going to create the transit gateway. So how can I create that? Let me go back to the where is this transit gateways? I will, okay, there is a transit gateway already. Let me delete it. We can use this also, but why I need to make the confusion for you? Create a transit gateway AWS B13 hyphen Ohio. Okay, simply create the transit gateway. Done. Now after that, what we can do here is, let me go back to the transit gateway attachment, but we need to wait until the transit gateway is created. Okay, so we will wait for that. Any questions up to now? Did you understand the process? What is happening in the backend? Guys, any questions?
So everything has become hodgepodge, sir. It is going
Sorry.
over the head.
Okay. Hold on. We need to wait for a while. Hold on. Okay. So now what I can do here is, let me check whether we got the transit gateway. Yes. I'll go back to my transit gateway attachments. Create a transit gateway attachment. This is my what I can say mgmt hyphen PGA for the management transit gateway. I'm creating this Ohio, and this is the VPC connection, management VPC. I am going to create a transit gateway attachment. And the next one is create a transit gateway attachment. This is my backup hyphen TGA, and this is my AWS B13 Ohio VPC type of connection. Why? Because we are connecting VPC to the transit gateway. Create the transit gateway attachment. So two transit gateways attachments are created. So this is my mgmt hyphen PGA, and this is my backup hyphen PGA. The CIDR is for the backup VPC. The CIDR is 10.100.0.0/16. For the management VPC, the CIDR is 10.200.0.0/16. We just created two servers, and both the servers are not communicating with each other. Now we need to establish the routing. So how can I establish the routing? Let me go back to the routing table. One is available. We need to wait for a while. Okay, let me go to the routing table here. For the management VPC routes, edit routes. So I will remove all this, or else we don't need to remove this. I'll remove these things. Okay, so if it has to communicate with the 10.100 means backup VPC, 10.100 means backup VPC, then we need to go with the transit gateway. Or else let me do one
The
thing. I will
screen is,
remove this
sir, the
also.
screen is not.
Is it visible now?
Yes.
10.
No, sir. Yes, sir. Now it's visible.
10.100.0.0/16. Then it needs to communicate with the transit gateway. Done. Save the changes. Now for the backup VPC also we are going to do the same. So let me go back to the backup VPC, routes, edit routes. So what is the management VPC CIDR? 10.200.0.0/16. It has to communicate with the transit gateway backup-TGA. Done. Now here you can see there is a communication establishment. There you go. One server is communicating with the another server. But why it happened here? It's a problem. Come on. Okay, so this is how you can establish the communication between the multiple servers. Let it come. Okay, so that is called as your VPC transit gateway connection. But the point is, if you want to make the communication between the multiple VPCs, if you want to make the communication between the multiple VPCs, how you can make the communication? What happened? Okay, fine. We'll get to that later. Here you can see. Now what you need to understand is, if the development VPC has to communicate with the management VPC, it has to pass between multiple transit gateways. So the point what you need to understand here is, it is a very tricky situation. First of all, from the development VPC, the data will be transmitted to your transit gateway. From the transit gateway, we are going to create a route. As you know that we have a route between development VPC and the transit gateway. We don't need to worry about that. By default, whenever you create the transit gateway, if you go to the transit gateway, you are having the routes. Transit gateway routing table. There you go. Transit gateway route table. By default, the transit gateway will know about the routes. Here you can see 172.16, 172.17, 192.168 means development VPC CIDR, production VPC CIDR, and test VPC CIDR. For all the CIDRs, you are having the connectivity. So the transit gateway knows about the CIDR connections. So you don't need to worry about that. But here the point is, what you need to understand. So the data will be transmitted from your development VPC to the transit gateway. That is fine. Now from this transit gateway to the another transit gateway, we need to have a connection. How we can establish that connection? To establish that connection, what we are going to do here is, go to the transit gateway attachment, create a transit gateway attachment. This is my Mumbai Ohio TGA. Between Mumbai and Ohio, I am going to create a transit gateway attachment. So what is the transit gateway? That is TGW, AWS B13 TGW. Attachment type is peering connection. Between the same what I can say, same devices, we can go with the peering connection. This peering connection is different from VPC peering. Don't think that both are same. VPC peering will be establishing the connectivity between the two VPCs. This peering connection will establish the connectivity between the two transit gateways. Both are different. Select the peering connection. Okay. So peering connection attachment. Where is the transit gateway? Transit gateway is in my account only. You can create the multi-account transit gateway connection also. But as of now, this transit gateway is available in my account only. So where is the other transit gateway? Another transit gateway is in the Ohio region. Select it. What is the transit gateway ID of Ohio region? Provide the transit gateway ID of Ohio region. Copy this. Go to your transit gateway acceptor is this ID. Provide the ID. Create a transit gateway attachment. Now the attachment is created. Now you can check in your Ohio region also. When we go for the Ohio region transit gateway attachment, here you will get a transit gateway attachment. Hold on. Where is this? Come on. Here you will get a transit gateway attachment. There you go. This is the Mumbai Ohio TGA. Oh, come on. Mumbai hyphen Ohio hyphen region. Done. Now what we need to do, we need to accept the transit gateway attachment. Hold on. Accept the transit gateway attachment. Accept. Now the connectivity is established. The connection is established. Still the routing is not done. So we have a connection between Mumbai and Ohio regions. Okay, this is the transit gateway which has been created between Mumbai and Ohio. Okay, done. Now, so what we are doing here, so the development VPC, first of all, what I will do, I will go to the development VPC. I'm going to show you only for one VPC. You have to do for the rest of the VPCs. Routing table, dev-route, routes, edit routes. So if the development VPC has to communicate with my 10.100.0.0/16, that is my backup VPC, and one more VPC is that 10.200.0.0/16. This is my, what I can say, management VPC. Then the data should be propagated from VPC to the transit gateway via transit gateway attachment. So whenever we are providing this route, the meaning is that the communication is not established. The meaning is we are unable to establish the communication, but still what we are saying here, you need to understand this point. From here the data will be transmitted to the transit gateway. Okay, done. So on the next point is, from the transit gateway it has to reach to this particular transit gateway. How it will be reached? For that, what we have to do here is, this routing table is for the VPC. Try to understand this, guys. This routing table is specifically for the VPC. Now transit gateway will have its own routing table. Go to the transit gateway routing table, go to the routes, create a static route. So if from the transit, from where the data should be propagated, up to here the work is done for the dev VPC. Dev VPC wants to transmit the data to the management VPC. So to transmit that, so the first thing is, from here to here the communication is done. So as we have provided the route, what I have specified, if the development VPC should communicate with my management VPC or backup VPC, first of all the data should be reached to the transit gateway. In the routing table it is done. And the next thing what we have to do here is, from the transit gateway it has to reach to the another transit gateway. So for that, what I have to do here is, let me go back here, 10.100.0.0/16, that is my backup VPC. Then the data must be transmitted over here. We need to get an attachment. Why we are not getting the attachment? Hold on, still attachment is in pending state. Peering connection is available. The peering connection is available. Why it is taking time? Routes, create a static route, 10.100.0.0/16. Then it should be transmitted to Mumbai Ohio transit gateway attachment. Create a static route, and again I can create one more static route, but for the another VPC. That is 10.200.0.0/16. So we need to go for the Mumbai Ohio transit gateway. Create the static route. Now the data will be forwarded from the transit gateway to the another transit gateway. As other transit gateway is having the route, here you need to understand this. Other transit gateway by default it is having the route. Here you can see in the Ohio region, if you see this, by default it is having the route. If you go to the routes, look at there, it is having the routes. So it can transmit the data to the management VPC or to the backup VPC. Now that's fine. Now whenever the data, so if when the data is reaching to this VPCs, the server has to provide the response. So how they will provide the response? If the management VPC or your backup VPC Go to the routing table, management public, routes, edit routes, add route. If they want to communicate with 192 dot, I understand, okay, 192.168 dot, but I can say 0.0/16, okay, 192.168.0.0/16. Then the connection should be 192.168.0.0 transit gateway. Here we don't have the internet gateway. That is the reason we are unable to connect. One thing, hold on. That is the reason we got the termination. Hold on. Done. So what I am specifying in the 10 200 means which VPC it is. 10 200 means management VPC. If the data has to transmit to the from management VPC to the development VPC, first of all the data has to reach to my transit gateway. That is what I have specified here. So to the transit gateway, save the changes. So what is happening here? So the data is forwarded to the management VPC. It is done. Reverse, the acknowledgement will be coming. So the management VPC will be forwarding the data to the transit gateway. Up to now it is clear. And from the transit gateway, here you can see the routing table is done. From the transit gateway, if it has to cross the region, then what we have to do, create a static route, and the CIDR is 192.168.0.0/16 to the development VPC. We need to provide the development VPC CIDR, and the traffic should be forwarded to Mumbai, Ohio transit gateway attachment. So now what is happening? From here, it will be transmitted to this transit gateway. As already transit gateway knows the region, so it will be reaching to the development VPC. That is what going to happen. So if you want to check out this, what we can do here is management server 10.200.1.199. So I will go to the so here I will give ping 10.200.1.199. Look at that. I am getting the connection from the management VPC to the development VPC. Not only that, we did not provide the route from the backup VPC. We have to provide the route from the backup VPC also. So how can I provide that? Go to the routing table, backup VPC, routes, edit routes. So in the backup VPC, I am going to provide the development VPC CIDR 192.168.0.0/16. It has to communicate through the transit gateway via transit gateway attachment. Now I will have the communication from the backup VPC also. Okay, 10.100.1.114. So here you can see ping 10.100.1.114. Look at that. You are getting the communication from the backup VPC also. So this is how you can establish the connections between multiple VPCs within the region or else between the multiple regions also with the help of transit gateway. That is what we have done today. Any doubts here? Guys, any questions? Any questions? If you see the diagram, you can get the clarity. Okay, so that's it from my end. Any questions, you can ask me now. Okay, so
like
yeah.
if there are more than 4 to 5 transit gateways, like there are so many VPC clusters, so we would be having one-to-one connections, transit gateway connections for each transit gateway. Suppose we are having multiple accounts and multiple regions, so and in a region and in an account we have 2 to 3 VPCs.
Okay.
So we would be creating transit gateways for each region and each account, and then we would be connecting all the transit gateways.
Yes, we can connect like that.
So like there would be many combination, right?
Yeah, you can, if you want, you can have the many combinations also.
Okay. So like
That
in real world industry practice, so like the combinations are there too many? Like what what kind of number would a company be using?
that depends. How can I say that?
Okay,
That
okay,
depends upon the server requirement. That depends upon the, see, every company don't require the transit gateway. Every company doesn't require the peering connections. If at all, if the servers in multiple VPCs has to communicate with each other, you can go with the peering or transit gateway. That's totally your wish. And one more thing here is each attachment. What? How many attachment we have created it now? 1, 2, 3, 4, 5, 6. Attachment cost is $0.05. One attachment will cost you around $0.05. So which
okay,
means $0.30 will be the cost. So transit gateway is not cheaper; it is costly. But
yes,
to overcome the this what I can say, to overcome the issues that are occurred by your VPC pairing, we are going for the transit gateway. Okay,
okay,
so that is what, that completely depends upon the company requirement. I cannot say that only one transit gateway is enough. I cannot say that you don't require the transit gateway. That totally depends upon the company requirement and your server requirement and your administrator. So the cloud administrator can ask you to create a VPC peering connections. Why we need to go for transit gateway? Why can't we go for the peering connection? We are having three VPCs. Then we can simply go for the peering connection. Okay, and not only that, a transit gateway can be acted like a VPN also. Okay, we can use the transit gateway like a VPN also. If time is there, I can tell you in the next class. Okay, so
thank you,
yes,
sir.
yep. So that's it from my end. uh, so let us go for the decommissioning. Any questions? So again, I'm deleting the transit gateway here. Any questions you can ask me now. Okay, then chalo, let me delete it. So don't forget to delete the transit gateway attachment. Delete the transit gateway attachments. Transit gateway is not costly, but transit gateway attachments are costlier. This is the problem. Hold on. Delete it, and slowly one after the other you have to delete. That is the main problem with the transit gateway or else VPC configuration. In Azure, we don't find this. If we delete the complete resource group, all resources will be deleted. With EC2 instance, sorry, with the VMs, virtual, everything will be deleted. But in VPC, we have this. I'm not saying that this is a problem. You can delete whatever you want. Okay, but in Azure, you don't find this. Anyways, coming back to this, let me delete the attachment in the opposite region also. Done. So, any further questions? Okay, let me delete the servers. Delete all the servers. Done. So that's it from my end. We'll meet on Monday and discuss about the security groups, which will be very interesting for you. So have a nice day. And so one thing that I want to say you here is actually, so I have terminated this instance also. Fine. Okay, I will tell you in the next session. Bye, guys.
Thank you.